Hello, welcome everyone. In this short video, we will look at IP addresses. And here are the objectives. We'll try to understand what an IP address is, and we will look at the classes that are available, subnet masks, and little things around IP addresses. And before I jump into the subject, let me make sure that we all understand that the topic here is, again, 10,000 foot overview of IP addresses, and this is not intended for network admins. This is basics for people who are trying to get into IT industry, and also for QA professionals who are trying to, people trying to get into QA industry. Okay, well, with that, let's get into the topic of this video, and let us start with the analogy. Let us take this example of a street. So the street name is Main Street, city Milpitas, State California, and we have 5 houses, and the numbers are from 101 to 105. So in United States, this would be the house, this would be the address of the blue house, 101, which represents the actual house, and here, and the rest, this would be the Main Street, represents the whole street. And this is very critical for you to understand that. So that represents the specific house on the street, and this represents the street, the whole street. Now, why is it important for these houses to have unique numbers? Say, for example, you have 101 here on the same street. Let's say instead of 105, let's say this is also 101. Now, what happens if you ever get a mail for the house 101 on the street? How does the postman or the mailman know where to deliver this packet? Here, or is it going here? No idea, right? That's a confusion. Now, this is how the TCP/IP works. This is how the IP addressing works, actually. Meaning every system within the network should have what? Unique IP address. If you have, just like here, where you had duplicate street numbers for these houses, and there's a problem delivering the mail, same way, if 2 systems have the same IP address, they will have what? Network issues. So with this example, let's get into the topic. Okay, well, IP addresses. The version 4, the current version is IP. The current version is IP version 4. IP version 4 is a 32-bit address, and the latest version is IP version 6. That's different. That's we'll not be discussing IPv6. In IPv4, the addresses are 32-bit long, and it is with the notation here in 4 octets, 8 bits dot 8 bits dot 8 bits dot 8 bits. So an example of an IP address you might have seen before, it could be something like this: 10.2.3.1. So each number here is from this 8 bits. So just a quick thing, a bit is either 0 or 1. So when you have 8 bits, so each bit could have what? 0 or 1. So now if you have all ones, then it would be 1, 2, 3, 4, 5, 6, 7, 8. 8 ones. That's what? A binary representation, and this is equivalent to 255 in decimal. So IP addresses are primarily what? Version 4 is the 30-bit addresses. Now, every IP address has two components or two parts. One represents the network and the other represents the host. So you have what? Network bits and host bits. So out of 32, some are network bits, some are host bits. So let us look into these IP addresses more. Okay, so IP addresses. So IP addresses are split into classes: Class A, Class B, Class C. In Class A, the first octet is reserved for network, or it represents the network bits. The rest represents the host bits. In Class B, the first and the second octet represents network bits. Third and the fourth represents the host bits. In Class C, the first, second, third are used to represent the network bit, and the last octet is for the host. So as we discussed before, IP addresses have two parts or two components, one for network, the other for host. This is similar to the address. Say the address that we looked at is 101 Main Street. This is the actual house and this is the street. This is the network, this is the host, when you are comparing the street address to this IP addresses. So as I said before, one octet is 8 bits. If you put all ones in there, it's 255 in total. And now when it comes to the classes, in Class A, the first octet value, so it's from 1 through 126, it's Class A. So anytime you see any address starting with, let's say for example, 125 dot something, so 6.7.8, just all you have to do is look at the very first octet, and if it falls in the range, the address belongs to that specific class. So Class B starts with 128 to 191. Class C starts from 192 to 223. Now, what happened to 127? So we said Class A is 1 through 126, and Class B starts from 128. So we actually skipped 127. 127 has a special role in terms of TCP/IP networking. 127 is here to give you an example. It's more like I in English. I represents, when I say I am representing me. When you use I, you're representing you. So within networking, it is using TCP/IP protocol. An IP address of 127.0.0.1 represents I. So on your machine, if you use this IP, you're representing your own machine. If I use this on my machine, and representing my machine, which is equivalent to the English thing I. So next, here is an example of an IP address, which is 10.2.3.5. So which class does this IP address belong to? So we will look at the first octet. It is 10. we'll look at in which class of range it falls into. It falls into this, so it's class A. Now, what is the network portion of this address? In class A, the first octet is the network portion, so 10 is the network portion. And what is the host? The host is the rest of the IP address, which is 2.3.5. Okay, so every IP address has two parts, host portion and the network portion, and you can use classes to determine the network portion of it. And that, again, this is very basic. There are other concepts like subnetting, supernetting that kind of throws curveballs at this total IP address understanding. That's a larger topic, and that's more for network admins. Anyway, this is like a basic introduction into IP addresses. Now with that, let's see if I have any more slides. Okay, I have a couple more slides. Okay, so subnet mask. So now what is a subnet mask? Let's see how you can calculate subnet mask, and then we'll talk about what a subnet mask is. To get a subnet mask for a specific network or for specific IP addresses, and if it is following the standard class-based IP addressing scheme, replace all network bits with ones and replace all host bits with zeros, and the result is the subnet mask. Say for example, our one of the IP addresses, say 10.2.3.5, we know that this is class A, and in class A the first octet represents what? Network. So, and the rest is the host. So according to these two rules, all the network should be all ones. So there are 1, 2, 3, 4, 5, 6, 7, 8 dot, then 8 bits here, 8 bits here, 8 bits here. So all the network portion should be 1. So we're going to put all ones here. When you put all ones, the total value in the decimal is 255, and all zeros in the host portion. If you put all zeros in these locations, it will be 0.0.0. So that's the subnet mask for class A. Similarly, for class B, we know that the first and the second octet are for network, so we get 255.255.0.0, and similarly for class C, the first 3 octet, meaning the first, second, and third octets are network, so we replace it by 1, or replace it with 1, and what we get is 255.255.255.0. One more slide to finish this video. Okay, simple network here. Let's take an example and talk about how this really works. Say for example, in case 1, we have two systems A and B connected to a switch, and here are the IP addresses. As you can see, it starts with 10. Both will start with 10, meaning they both are on the same network. So once they are on the same network, meaning they can be with the switch, they can talk, the packets will switch from here to here, everything is good, they will be able to communicate. Take the case of 2, D and E. D has an IP address of 10.1.2.1, that is 10, and E is starting with 180. So 10 is a class A IP address, 180 is class B IP address. That means they belong to two different networks. When you have these systems connected to a switch like this, they will not be able to communicate. The the system should have IP addresses that belong to the same network to be able to communicate with each other when they're connected to the switch. In order to address this situation, you would need a different kind of network, meaning you would, let's say I'm going to put D here. So you had an IP address of 10.1.2.1. You need a router to be able to route the traffic. See, because this is what network 1, this is network 2, 180.123.1.3. Because the router is a device that can route the traffic from one network to another IP network. Switches cannot. Whatever you have here, whatever systems that you connect, they should all belong to the same network. If they belong to the same network, they will be able to communicate. If they belong to a different network and they have a switch that is connecting, they'll not be able to communicate. For this to happen, you really need a router in between. Again, we will look at we will look at an example where let me fix this one real quick. Okay, gotcha. Okay, we will in one of our other videos we will take the case of a system connecting to internet, and we'll discuss how routing happens and how the packet from your computer goes into the network, and how a web page is displayed, and we'll take the case of router and try to understand more there. But for now, I would like you all to understand that when systems are connected using a switch, all the systems should have IP addresses that belong to the same network. And for the systems with the different IP addresses falling into different network, then they would need what? A router. Okay. Again, this is a very basic introduction into IP addresses. This is a very larger topic, and even the network administrators kind of get confused with all this, at least when they're trying to get into the networking world. As a QA tester, if you start off with this basic understanding, this will take you miles. I hope you enjoyed this video. Thank you very much.